All right, so we're going to continue chapter 6. We're going to start section 3A, which is solving right triangles. So we've done evaluating trig functions using right triangles, but now we're going to solve right triangles, meaning we're going to find all the sides and all the angles. All right, so here we would use SOHCAHTOA and sometimes Pythagorean theorem if that's your preference to solve for the missing sides and angles of a right triangle. Right, all the capital letters are going to denote your angles, all the lowercase letters are going to denote your sides. You can use any trig function. You really have a lot of options in these kinds of problems, and you're going to see once we go through them. All right, so I want to solve the right triangle. Make sure you have a calculator and it's in the correct mode. Here we're using degrees, right? So make sure your calculator is in degrees. So we start by first labeling all the information that we have. Right now I have an angle A of 31.67 degrees. And then I have a side A of 35.9 kilometers. All right. Now, start by counting how many angles you have. We have angle A that we were given, and we also have that angle C is a right angle. So if this is a right angle, I know that B and A have to add up to 90 degrees, right? So the two acute angles in a right triangle are complementary, meaning they add up to 90. So I can take 90 and take away 31.67, and that's how I get my angle B, right? So we do that, and we get 58.33 degrees. All right, so we have all of our sides. Now we want to find all of our angles. Sorry, I said that backwards. We have all of our angles. I want to find the sides. Here I want to see what kind of side we are given. We are given a leg. So if we are given a leg, we can use any of our three trig functions we want to try to find a missing side. So let's say I want to find side B. I don't know what side B is, but if I look with respect to this angle B, I see that this side B is an opposite. And then with respect to angle B, side A is going to be an adjacent. Right, so adjacent and opposite, we're going to use tangent to try to find it. Now, you really could have used tangent of another angle to try to find it. So if you did 31.67, you can still do that. You can also use another one, right? You could use sine or cosine and try to find a hypotenuse, right? But here, I would just want to find B first, right? So I'm going to do tangent of 58.33. is my opposite, which is B, over my adjacent, which is 35.9. Now to get B by itself, I would multiply 35.9 on both sides. All right, so we get 35.9 times tangent of 58.33. Plug that into your calculator, and we should get that side B is 58.20. Or I guess 2, right, to the nearest tenth, it says. All right, so then from here, we can do either another trig function if we wanted to, or we could use Pythagorean theorem to find our last side, right? The last side that we're missing is the hypotenuse, right? So if we're missing a hypotenuse, I can do a squared plus b squared equals c squared to try to find it, right? So why don't we try that here? All right, so I try that, and we're going to do 35.9 squared plus 58.2 squared. All right, so we can plug that into our calculator. And we get 4,676.05 equals c squared. And then we can square root both sides, and then we get my side C is 68.4, right, to the nearest tenth. All right, So really nothing too crazy. We'll do it a couple of different ways in the next few problems, right? We'll use a variety of different trig functions. All right, so once again, let's label the sides that we're given. I'm given an angle B is 47.8, and I'm given a side C is 89.6. All right, keep in mind this side C, this is a hypotenuse. All right, so we are able to find either of our legs. Before we do that, let's try to find our missing angle A, right? So if we have two angles in this right triangle, we can easily find the third, right? So I know that A and B have to be complementary, so I can do 90 minus 47.8, and that's going to get us 42.2. So I get 42.2 for angle A. All right, so we have all of our angles, and now we have to try to find all of our sides. We have one side, our hypotenuse, so let's try to find the other two. I'm going to start with finding side B. All right, I don't know what side B is, so we can use any of our trig functions to solve for it. I'm given a hypotenuse, and let's say I want to use angle B to try to find it. Well, I know that side B and angle B are opposites, so if I need an opposite and I have a hypotenuse, I would use sine. All right, SOHCAHTOA, so it's going to be sine of 47.8 is my side B over my hypotenuse, which is 89.6. All right, and then to get B by itself, I would do 89.6 on both sides. And then I get B is whatever you get when you do 89.6 times sine of 47.8 in your calculator. All right, which to the nearest tenth should get you 66.4. All right, now we have two sides. We can find the third using Pythagorean theorem, but let's try to use another trig function to try to find it, right? So side A is with respect to 47.8 and adjacent. So let's use the same angle. Let's just use cosine, right? Because cosine has to do with the adjacent and a hypotenuse. So I'm going to do cosine of 47.8 equals A over my hypotenuse, which is 89.6. Once again, I would multiply 89.6 on both sides to get cosine by itself. So then we get A is 89.6 times cosine of 47.8. All right, which to the nearest tenth is going to get you 60.2. All right, now we have all of our sides, we have all of our angles, so we solved our triangle. All right, now not all the time are you going to be given the triangle drawn to you. Sometimes you have to draw it yourself. All right, it tells you that C is the right angle. So I'm just going to draw a triangle with C as my right angle. So I'm going to say this right here is my angle C. I'm going to say that this is A and B. All right, and I'm given angle A is 61 degrees, and I'm given side B is 39.2 centimeters. All right, so once again, I have two angles here. I can find the third by either adding A and C and then subtracting it from 180, or since this is a right triangle, I can say A and B are complementary. So that means this side B has to be 29, right? 90 minus 61 is going to get you 29. All right, so now that we have all of our angles, we can start by finding our sides. All right, so I'm going to start with finding side A, right? I don't know what side A is going to be, but we can use SOHCAHTOA. We're given another leg, which is 39.2. If I want to use two legs, then I have to use tangent, right? TOA, opposite over adjacent. So I'm going to say tangent of, I'm going to use 61. All right, doesn't matter which one you do, is going to be A over 39.2. All right, and then to get A by itself, I would multiply 39.2 on both sides. All right, now I'm just going to take this moment just to show you, if I had done tangent of 29 degrees, all right, so I'll do that to the side. If I have tangent of 29 degrees, that means on top I would have 39.2, and on the bottom I would have A. All right, there's nothing wrong with doing it this way. You just have to do an extra step to get A by itself. If I multiplied A on both sides, I would then have to divide tangent of 29 on both sides, right, which will still get you the same answer, but it's just an extra step. So that's one thing to be mindful of if you want to save yourself a little bit of work, right? Just think a little more about what's going to get you your missing side on the top. So that way all you have to do is multiply by whatever's on the bottom to both sides, which is what we did here. All right, and then 39.2 cancels out. So then A is going to be whatever you get when you do 39.2 times tangent of 61 in your calculator, which is going to get you 70.7. All right. Now, once again, you can use Pythagorean theorem if you wanted to, or you can use another trig ratio, right? So I want to find angle C, side C now, which is our hypotenuse. So I can really use whichever angle I want to. Why don't we say sine of 29 is our opposite, which opposite of 29 is going to be 39.2 over my hypotenuse, which is C. All right, so this is what I was just talking about before with the tangents. Now the variable that we're looking for is on the bottom, right? So to get it out of the bottom, I would want to multiply by it on both sides, cancel it out over here, and then I get C times sine of 29 is 39.2, and then divide by sine of 29 on both sides. All right, and then this cancels out, and then this right here is going to get me my answer, right? So if you plug in 39.2 divided by sine of 29 in your calculator, you should get that C is 80.9. Right? If you did Pythagorean theorem, you might have gotten the same answer or something close to it, right? If your answer is off by a little bit, like maybe you got 80.8 when you rounded it, it could just have to do with the fact that this 70.7 right here is a rounded answer. So it's going to throw our answer off a little bit. If that happens, no worries, right? As long as your steps are correct, you'll get a similar answer to this, right? As long as it's not off by more than a tenth, right? All right, so we can do the same thing with the next one. All right, so this one, once again, I would draw a triangle. We are not given a triangle, right? Our angle C is going to be our right angle. I'm going to say this is A and this is B. Let's label everything we have. I have that B is 46, C is 29.7. So I can easily find angle A by subtracting 46 from 90. That's going to get me 44 degrees. Right, so now we want to find all of our sides. I can use SOHCAHTOA to figure out what a missing side is, right? We can try to find A. I'm going to try finding A using, I'm sorry, I labeled it wrong, B. I'm going to try to find B using angle A. And if I want to use angle A, then B is going to be an adjacent side, right? And we're given a hypotenuse, so I have to use a hypotenuse. So why don't we say cosine of 44 is B, which is our adjacent, over our hypotenuse, which is 29.7. All right, so then I can multiply 29.7 on both sides. All right, cancel it out, and then 29.7 times cosine of 44 is going to get you your answer, which is going to be to the nearest tenth, 21.4. All right, now that you have two sides of a right triangle, you could use Pythagorean theorem if you wanted to. I'll use another trig ratio. Why don't we do sine? Doesn't really matter, right? If I did sine of 44, that would get me my opposite side. All right, so we could do sine of 44 is my opposite, which is A, over my hypotenuse, which is 29.7. All right, so then once again, multiply whatever's on the bottom on both sides. And then I get A is whatever I get when you do 29.7 times sine of 44, which is going to get you 20.6 to the nearest tenth. All right, now that's all of our sides, and we have all of our angles, so we solved the triangle. We're good. All right, so we're going to try some more problems. You're going to see that this one's a little bit different, right? Because when we draw and label the triangle, you're going to see that we don't have the same information as we had before, right? So I'm going to say my right angle C is right here. I'm going to say that this is angle A, this is angle B, and we're given a side A is 958 meters, and my side B is 489 meters. All right, so with this information, I can find side C, my hypotenuse, using Pythagorean theorem. If I have A squared plus B squared equals C squared, that's going to get me 958 squared plus 489 squared. All right, now if you plug that in your calculator, you're going to get a big number that's going to get you 1,156,885. And that's my c squared. All right, and then you just square root that to get your actual c value. So if I take the square root of this, I get to the nearest tenth, 1075.6. All right, so we have all of our sides. I'm missing two angles though, right? So we can't do what we did before and subtract from 180 or subtract from 90. All right, we have to do something a little bit different. So what we can do is we can use a trig ratio to try to find our missing angle. All right, so let's say I want to find angle A, right? I don't know what that is. Let's try to find it. If I want to find angle A, well, we have all three of our sides, so we have options. I would use my opposite side and my adjacent side to try to find angle A, just because these are unrounded answers, right? This 1075.6 that we got was a rounded answer. So if we use that number, you'll get a pretty similar answer to what it actually is, but you won't get the exact answer, right? So just keep that in mind. And now opposite and adjacent, we know that that's tangent. So I know that if I do tangent of A, whatever A is, then I can do opposite, which is 958 divided by 489. All right, so a lot of you will just do 958 divided by 489 in your calculators. In this case, that wouldn't give us the answer that we're looking for. That will give us tangent of A, right? So to get just angle A, I don't want the tangent of A, I want the angle A. So to get my angle A, what you can do is you can use an inverse function. I would do tan inverse to cancel out tangent on both sides, and then I get A. My angle A is going to be whatever you get when you do tan inverse of 958 over 489 in your calculators, right? So now if you do this, right, let's see what that gets us. That gets us that angle A is to the nearest, I guess it rounds up, it's going to be 63 degrees. All right, so A is going to be 63 degrees. And then we can very easily find angle B now, right? I know A and B have to be complementary, so I know that angle B has to be 27 degrees. All right, so a little bit different from what we did before, but not any more difficult, right? Just required different steps. All right, so we can try the same thing for number 6, right? So I'm going to draw my right triangle, right? We know that angle C is our right angle. And I know that side C in this case is 39.7 centimeters. I'm going to say that this is A, and I know that side A has to be 26.5 centimeters. I don't know angle B, I don't know side B, and I don't know angle A. Right, well, let's use one of our trig ratios to try to find, let's try to find an angle this time, right? So let's say I want to find angle B, right? You could find angle A if you wanted to, doesn't really matter. If I want to find angle B, well, we can use SOHCAHTOA. I have, with respect to B, an adjacent side and a hypotenuse, right? So I'm going to use cosine, right? SOHCAHTOA. So I have cosine of B is going to get me my adjacent, 26.5, over my hypotenuse, which is 39.7. So what we can do is we can do what we did before and use an inverse trig function. I can use cosine inverse of both sides to cancel out cosine. And then I get B is cosine inverse of 26.5 over 39.7. Right, and so you can plug that into your calculators and then see what that gets you. All right, so I got for angle B 48.1. All right, now that we have angle B, we can find angle A. Right, angle A is just going to be 90 minus whatever we got for angle B, which is going to be 41.9. All right, so what we can do now to find our missing side A, we don't even need to use Pythagorean theorem. I can just use another trig ratio to try to find my angle A, right? So let's say I want to use sine. I want to use sine of 48.1 because that's going to get me an opposite. So that means A, we can use sine of angle B, which is 48.1. is my opposite A over my hypotenuse 39.7. Right, so then we can multiply 39.7 on both sides, just like we did before, cancel it out, and then we can plug in 39.7 times sine of 48.1 in our calculators, and then we should get that A is about, to the nearest tenth, 29.5. All right. So that's all for this lesson with solving right triangles. The lesson after this, we are going to solve any right triangle. We're going to start with the law of sines and then get into the law of cosines, right, to try to solve any triangle, whether it's a right triangle or not.